Intervals of increasing, decreasing, and constant. So moving from left to right, we can describe whether a function is increasing, decreasing, or remaining constant, and we describe it using domain intervals. For example, the function to the right is increasing from negative infinity all the way until right here at x equals -1. So we will say from negative infinity to -1. We'll put a parenthesis around the -1 because technically at -1 we are no longer increasing. We transition to being constant because the function is flat, not going up or down between those two values. So we'll say it's constant on the interval from -1 over to +4. And then decreasing starting at +4 and going to infinity. We can give the intervals of increasing and decreasing for this next function as well. So again, increasing meaning it's going up from left to right. So it's going up from left to right from negative infinity to that value, x equals 2. But then it's also increasing once again from 4 to positive infinity. So we'll put a little union symbol and say 4 to infinity. This function is not constant anywhere on this graph. It's not flat. In between those two values is where it's decreasing. So we will say decreasing on the interval from, I'm not sure why I put a negative there. That was +2. Sorry, we are decreasing between +2 and +4. That section right in the middle of the graph where we decrease for a little bit and then we return to increasing. So if we were asked about where is it constant, we would just say NA because we don't have any place on this graph where it's flat, so not applicable. Or you could say none. All right, so our next topic then is boundedness. And boundedness refers to the vertical restrictions on a function. Bounded above means the function has a value that it never climbs above. So if we take a look at this downward facing absolute value function, right here, we could draw a line that is its boundary above the graph. It does not go above the vertex there. Bounded below means we could draw a line underneath it because it has a value that it never dips below. So this is an even polynomial graphed here, and we can see it's got an absolute maximum there. It will never go any lower than that, so it's bounded below. It's not bounded above because it's continuing up to infinity, or the absolute value graph was not bounded below because it's continuing down to negative infinity. Bounded refers to a function that's bounded both above and below. So what we have in this next one is actually a sine or cosine wave, which we will talk a lot more about in this course. We're just going to fix it a little bit. We're going to put some endpoints here just so you're not confused. It's not continuing up to infinity or negative infinity. It's going to oscillate and just bounce up and down with that same pattern. But I think if we put the endpoints there, it'll make that a little more clear for you and not have you confused by arrows there. So what we could do with these graphs is draw a line to bound the top, and down here underneath, it will never go higher than those maximum values or lower than those minimum values. So it is bounded, trapped between two values there. And unbounded is a function that we can't do that. We can't draw a line below it that it would never cross or a line above it that would never cross. It's continuing down to negative infinity and positive infinity. So if we take a look at this first example here, number 5, we see, well, it's not bounded below because that piece right there is headed down to negative infinity, and up here we're headed to positive infinity. So this graph is unbounded. And the next one we have the equation for. So we are going to graph this in order to take a look at what the picture looks like to figure out, is it bounded above or below? So again, go into y equals, clearing out our previous function, and we will type in square root, reminder is second x squared, so that blue second button, and then 1 minus x squared underneath our square root. So here's our graph, and what we can see is that this function is bounded. We could draw a line underneath it at y equals 0 and above it at y equals 1, and our graph would never go beyond those values. So we will say bounded above by y equals 1, bounded below by y equals 0. That function is trapped between those two values and never goes above or below them. All right, so let's take a look at this next one. So clear it out. We've got x squared. Again, we need square roots, so second x squared, x plus 4. Move my picture a little bit here. All right, so what we can see is it's continuing upward forever here, but we are bounded below. It's never going below 0. So this one is not bounded above, but it is bounded below by y equals 0. So bounded, we're just referring to could we draw a line that it would never cross, either below the function or above the function.